Thank you very much. It's been a pleasure to be here today, hearing all the nice presentations. I will give you a very brief presentation about some of the activities we do within Materialise. I start with this picture. It's this baby boy. He was born in a hospital in New York with a quite complex congenital heart disease, and he was diagnosed already in the womb with this problem, and it was a quite poor prognosis for this little kid. He was at least facing a number of very critical surgeries when he would finally be delivered. But given that they had some, I go back again. Given that they diagnosed this condition already in the womb, gave some time for this for the doctors to plan what to actually do when he was delivered. So on the first day of his life, he was taken to a CT scan, and the images from this scan was then handled with software from Materialise in our software suite called Mimics. They created this 3D model of the heart so that the doctors could start to see how could they actually try to help this little boy. They couldn't get to the final decision how to actually operate, only based on the CAD model. So what they did in parallel was also to order a model, a 3D printed model in stereolithography. So the day after the day a boy was born, they had already done the CAD model. They had printed this part, and it was delivered the day after, so they could have a more clear picture of what they wanted to do. And when they got this model in their hands, they realized that they could use this model to really understand what they needed to do, leading to that they found out that they could manage with only one surgery. So from being unsure in the beginning, maybe having to start the operation and just take it as it goes, they could define a way to go. They managed to do the whole operation in one time, and the boy is now recovering, and the projection is very, very bright. This is one of the things that we are doing within Materialise. We have come quite a long way since this guy, our founder and CEO, Fried van Kren, bought the first stereolithography machine from the university in Leuven and started the Materialise company. But he had already from the beginning a very clear vision of what he wanted to do with this technology. He wanted to create a better, healthier world with the help of meaningful applications in 3D printing. And the first example I showed you is quite an obvious, it's a nice one. I will show you some other things along the way here in the presentation, what we are doing. But already from the start, they realized and started to see that there are several competences needed to be successful in the additive manufacturing world. So apart from the 3D printing itself, where we are today producing in 7 different technologies, we have more than 150 machines running in both plastics and metal. They started to develop software to handle CAD data, convert 2D to 3D at that time, leading all the way to the Mimics suite that I showed you in the beginning. Also developing software to run the 3D printing machines themselves. the build processors. And as well, understanding design and engineering for getting the most out of these technologies when you start to produce parts. Today, we serve customers in a large range of different businesses, from the healthcare business through design, fashion, aerospace. We're certified for supplying plastic parts to the aerospace industry, automotive, you name it. A lot of interesting applications we use this technology for today. Quickly going back a little bit more to the medical field, what I showed in the first case was where we use our software to prepare a CAD file based on CT or MR scans, building a visual model for understanding or pre-surgery applications. We also produce tools and surgical guides that are used in operations. For instance, we produce customized knee guides based on X-ray or CT images. Fully customized, unique parts. We deliver 6,000 to 8,000 of those per month to speed up operation time, improve quality in the surgery. And we also produce customized implants, so for instance, for hip implants. And our latest achievement is that we just a week ago we got a clearance by the FDA to supply our maxillofacial implants in titanium to US customers. So this is some of the areas and things we do within the medical field. Myself, I'm working in the manufacturing division of Materialise. We are focusing on industrial applications, other business-to-business applications. And I'm going to talk a little bit about digital supply chains. This is quite a hot topic today. It hasn't been that much discussed in this seminar today. It has been a lot about different technologies and materials and things like that. We are more using the machines for different applications. And in our world, the digital supply chain is quite hot, as I said. Many companies are looking into what can 3D printing do for their business. Can it, I mean, they are dreaming about producing parts on demand, reducing stock handling, minimizing transportation, minimizing material waste, things like that. And last year there was a report by PwC talking about optimisms and dreams for tomorrow, how the digital supply chain could or will reinvent the way we produce parts or supply parts. I want to show some cases where this is not necessarily something for tomorrow. It's something we do already today, and we have some nice examples. Starting with Fitz Insoles, a company that produces customized insoles to give better performance to and prevent injury in different situations. So what you do is that you take a dynamic scan of your foot movement, and this scan data is analyzed by software, and it indicates where your foot needs support while you're running, while you're walking, while you're working. There are different ways to do this, or different softwares depending. There is one for golfing, there is one for tennis playing, etc. And this analyzed data is then sent to Materialise software that creates a CAD file based on this analyze to create the necessary support where needed, and is then sent directly to production. So it's an end-to-end solution. You start with nothing more than you coming into the shop, doing your scan, and after a certain time, you have a produced, unique, customized part. For this technology, we use PA12 in laser sintering, and in this case, we don't need to do a lot of finishing. We would put on this top surface on the insole. Another example is the Unico system that is developed together with Hoya. Hoya is a lens manufacturer, supplying lenses to all different kinds of eyewear manufacturers. They wanted to have a more vision-centric approach to making eyewear. And what does this mean? It means that typically when you go to, or how you do it today, when you go to your optician, you choose your eyewear frame, you take your examination, and the optician prescribes what the lens should be like. Then they try to fit this lens into the frame, and then you go. Hoya wanted to turn this around, because ideally, you would like to position the lens in an optimal position in front of your eye, and not be steered by the frame as it is today. What if you could instead position the lens and build a frame around it? In that way, you could always have the optimal position of the lens. And study shows that if you can do that, you can improve the visibility performance with up to 20%. So it's quite a performance enhancement if you can keep the lens in the right position. So that was the vision. That was the idea that they wanted to do. And how did we do that? We, together with them, developed a scanner that is used at the optician to scan the face, the anatomy of the face. Some software is taking out the most important parameters, and then the file is sent for 3D printing. So the procedure when you come to your optician would be that you take a facial scan. This is something that is done in a few seconds. The optician makes the regular examination, prescribes the lens type you should have. You make a choice of the design of the eyewear frame, but it's not the eyewear frame that you will finally get. It's just the design, the style of it that you choose. Then you choose what kind of lens you need to put in there. It's sent to production, and the lens is mounted into the frame after it's produced in the right position, and then it's delivered to the customer. So this concept is now rolling out. We started to deliver the first systems just before summer, and it's a unique open platform, so it's there can be different eyewear manufacturers who can join this platform or use this platform. The eyewears themselves we produce in PA12 again, and there is a special finishing concept that we call Luxura for this kind of applications where you need to fulfill a lot of different parameters to work as well, regarding skin contact and these kind of things. Finally, an example from the industry, where we also created a complete digital supply chain. The company Schunk, producing, among other things, grippers for the industry, they wanted to have a simple, an easy tool to order grippers. So this is a system that is developed where they use our software to, in a way that the customer just upload a file of the part that they want to grip, and the system automatically calculates how should this gripper be designed around that to grip it in the right way. So this is something you do in front of your computer. You upload your file. Within 15 minutes, you can have the complete design made and ordered. So what happens is we just get a file. It's designed automatically and goes directly to order and manufacturing. And as this representative from Schunk says, first they were trying to find a way to produce grippers in a more efficient way, but in the end we actually reinvented the complete way that they could do this. So that are some examples of what we do within Materialise. Any question?